The assignments for this lab involves three additional user-defined statistics. The first user-defined statistics that you need to implement in your Simio model of the queuing network that we discussed in the videos is essentially an alternative interpretation of the time between station B and D. So in the current model, note that because of the way we implemented the logic, we essentially overwrite the arrival time at station B every time the entity visits the station. So what the current user-defined statistic reports or measures is the duration of time from the last visit into station B until the time that the entity leaves the system. And again, depending on how you interpret this metric, this can be a valid statistic. However, this time, suppose that we are interested in the time between the two stations from the perspective of individual parts. In other words, we would like to estimate the duration of time that an entity spends in this subsystem from its first arrival at station B until it leaves the system. So you guys need to add a new user-defined statistic to measure this alternative interpretation of this metric. And do not modify the existing user-defined statistic. I want you to start from scratch by defining all of the necessary state variables. So the second metric that we're interested in is the total time in queue at station D. Now remember that Simio has this built-in statistic that reports the time in queue for a server object. However, when you think about this statistic, this is really an estimate of the time in queue per visit. So every time you visit this server, the statistic tells you how much time you expect to spend in the queue. Now suppose, because of this reentrant flow that we have in our queuing network, suppose we would like to measure the total time that an entity spends in the queue for station D on average, but this time from the perspective of individual parts again. In other words, we would like to estimate the average accumulated time that an entity spends in the queue at station D over all of its visits to this station. So we would like to accumulate the waiting time if the entity visits the station multiple times. The third performance metric is the closing time and overtime cost. So in order to do this, I want you to modify the model by assuming that the system operates for 16 hours from 8 a.m. to 12 a.m. Such that new parts are allowed into the system until 12 a.m. But the facility will only close when all of the work in process are finished. So we want the run to end with an empty system. Assume a $450 cost per hour of overtime, and I want you to define a statistic that measures the total overtime cost. I want you to create an experiment and define 7 responses for the 7 user-defined statistics that we covered in this lab, both in the videos and the assignments. I want you to use the resulting SMOR plots to justify the number of replications, and also include the SMOR plots in your report document. You should also include a clear description of how you coded each of these 3 user-defined statistics in your Simio model, along with snapshots of different components and steps. And finally, as always, you will find the submission requirements in the lab document.